Welcome to day 6 of Advent of Code. Today the question is a little fun. Here we have to, as per the story, we've gone traveling to the past, to 1518, and here there's a guard which is guarding one area, and we are not supposed to let anyone from that time see us, so that we don't have a time paradox. So this input is basically showing us the map of the area, and this arrow is the direction in which the person is facing. So if it's up, it's if it's pointing upwards, it means the person is facing upwards, this guard, and she is currently facing upwards. The guard has to follow certain rules, one of which is if something comes in front of it, then she has to take a right turn every time something comes in front. So these things are some things which will block the way, these hashes. So now what we have to do is we have to trace the guard's path and see how many locations she covers. So here in this example, these are the locations that are covered, which are 41 distinct positions. So I think we can do it quite easily. Let's try it. Alright, so I think this isn't the most optimized code. I can definitely clean this switch case up a little, but for the first thought I just wrote it. I'll probably upload the cleaner version of this on GitHub when I do, but anyway, let's start. So first we're processing the input, pretty standard as per what we've done so far. We're splitting it by the new line character, and then we are splitting each of the characters within it. So then we get basically a 2D array of all the positions that exist. Then we're looking for a starting position, which means we're looking for this up thing. I checked, I mean, they haven't mentioned it in the question whether there would be other directions apart from this. So we are going to assume this is the only one. And I also checked the dummy input, the actual input. So they are also using this. Now these two things were done, and so I'm keeping track of something called next direction. In this case it doesn't make so much sense because I'm doing it localized to that direction right now, but if I clean this up, this will be very useful. I had thought about doing it that way when I thought about it in my head, but I messed up while writing the code. But basically what this is doing is if you're going up, the next direction would be right if you meet a collision. Similarly for right it will be down, for down it will be left, for left it will be up. Then we are going to loop through each position. We're just checking if we are going out of bounds, if the guard has gone out of bounds, and stopping at that point. And this is like somewhat of a future check. We could do this as a do while, in which case this would be fine. Like you would just put xy and put the bounds. But here, since we start doing a while loop, we are also adding the existing visited positions. Oh yeah, I didn't explain this part. So visited positions are a set of all the positions that we've been through, and it's a set because anything which is being repeated will not be added, will not be duplicated, so the count will be maintained perfectly. Current direction is up, we know that we've hard-coded it. Since we don't have any other directions, I've hard-coded it. The starting location is this, which we find here, is what is here. X is the I mean row, and Y is the column. Then visited positions, we are adding that, and then we are looping through this. If we are going up and it does not meet a collision, then we will keep going up. So for the same way for every other direction. And if we do meet a collision somewhere, or like a block in the path, then we will change our direction and continue. So that's what's happening, and we are getting 41, which is what is expected from the sample input. Now let's try with the actual input. I'm going to follow the style since I liked it the last time. 5131, let's hope for the best. Great, we did it. Let's see what the second part has for us. So in this part, what we have to do is, we found the number of positions that this guard visits, but now we have to we could see that here the number of positions that were being covered were way too high, and there was no like proper place where the historians could travel by properly around this place, and they felt like there was a risk of getting caught, which was very high. So instead what they thought is they could place an obstacle on the way of the guard, so that the guard ends up in a loop, and they'll know that the guard is only going to go in those spots. So now we have to find out all the possible locations in which the guard can we can place an obstacle. So one is this, which is right next to the starting point. So then the loop will continue. The loop will form there, or like there are so many where you can come this way and then the whole loop, and then you put an obstacle here, so then this thing continues, you form a loop here. And they've given some examples like that. Now we have to find out how we could come up with such a loop. Cool, so let's do that. Okay, so in this part 2, I've cleaned up some part of part 1. The initial part is the same, processing input, finding the starting position, next direction, all that is the same. Find distinct positions is also pretty much the same, except I've added this thing, check for loops, so that I can do two things with the same method, which is not a good thing to do because it does not follow a single responsibility principle. But in this case, I think reusability of code was more important to me. So here everything is the same, except I've changed visited positions to a map instead of it being a set now, and I'm keeping a track of the direction as well. So here, instead of keeping a if and else condition for everything, I've cleaned it up. so that we just mark the next location, and in that, if the next location is not a hash, then yeah, we mark the next location, otherwise we change the direction. That was the same as before, the older logic. But and before we were adding to the set, now we are adding to this the visited position map. But now we've added this thing, if it is checking for loops and there is a visited position, and the visited position matches the current direction in which we are going, which means we have formed a loop. When does this happen? First, we will get all the positions that are being traversed or being like visited by the guard. Then we will use this, and we will basically hard code. I mean, we will brute force our way, in which we will use every position as one of the new blockers or whatever it is, like something kept in that position. We will do that through everything, and wherever it forms a loop, we will know that okay, this is looping. So we've got a loop count from that. This is slow. It took me around like 6-7 seconds to get this answer. That's why I ran it before. Now let's see if it works. Okay. Great. This worked. It was, I mean, I'm not very happy with the brute force approach, so I'm going to take a look. In the previous days thing, I think I watched a lot of videos on how other people did it, and it was pretty much the same as what we did. So I don't think there's a more efficient way to do that, but I'll keep an eye out, and you guys, if you know it, let me know. Thanks, and see ya in the next one. Bye bye.